Hello everyone, my name is Michael Fitzgerald, and today I will be teaching you about STP, or the Spanning Tree Protocol. What are we going over? Well, we're going to learn about the Spanning Tree Protocol and what it is, what some of the port rules are, some of the states that the ports are in, what the BPDU, or Bridge Protocol Data Unit, is, and what it does, what a root bridge is, and some of the types of the STP that are out there. What is the Spanning Tree Protocol? The Spanning Tree Protocol is a feature used to prevent loops that want to use redundant switches. This can cause a lot of problems for the switches just because a loop could create a broadcast storm. A broadcast storm is when a switch sends a broadcast message and that message loops back, but the other switch sends out a broadcast message at the same time, making it so it gets bigger and bigger and bigger until either the switch breaks, it gets disconnected, or you have to come disconnect it yourself. When the broadcast storm happens, it can create an unstable MAC address table, which in hindsight is very bad because let's say switch A wants to send uh, a packet back to switch B, but it already has a MAC address saved into its MAC address table, and that MAC address is switch C, which could be very bad. And also, it could duplicate frames, sending, for example, switch A could send a frame to switch B and C, and then switch B will send that same frame to switch C, so switch C will get two different frames. Looping is also fixed by blocking a port, which we'll get into a little bit later on. Ports are always in a state of being, which means that it can be disabled, which is just shut down. It could either be in a blocking state, which makes it so no traffic can go through the link or port. Another state is listening, which just means that it's not forwarding traffic or learning the MAC address of the switch that that's sending packets to. And then there's the learning state, which it doesn't forward traffic, but it learns the MAC address of the the switch that's sending packets to it. And then there's the forwarding state, which is sending and receiving packets normally. Now I'm just showing you the example that I'm going to be using throughout the rest of this presentation. It's a layer 2 typology, and it has 1 gig links in between. The BPDU, or the Bridge Point Data Units, are data messages that are exchanged across the switches within a LAN using STP. These messages contain the root cost, the root, and the local bid. Bid stands for bridge ID, which is a very key factor in figuring out your bridge port. Your bridge ID is a default of 32,769 followed by your MAC address. Example is right there. My bid is 32,769 followed just by a made-up MAC address, and that's the same for your root bid. Now let's try to find the root bridge. A root bridge is basically the main switch. How to find one is by looking at the numerical value called a bridge priority. A bridge priority is defined by the IEEE 802.1d standard, which is equal to 32,769. Most switches will have this default, and if that is the case, then you'd find your root bridge by going to the lowest MAC address of the switches. If you want a specific switch to be the root bridge, then you'd have to change the numeric value, the bridge priority, to a lower number, so it prioritizes that over the other switches. After finding which switch is your root bridge, then you'll be able to figure out which of your ports are in the forwarding state. And whatever ports are in the forwarding state, at the end of those switches are the root port. And the root port is the best route from the non-root bridge. And root ports are based on port cost. This is the easiest way to find a port cost. You'd have to look at the link, which is either gigabyte connection, megabyte connection. Right now we're using 1 gigabyte per second, so we'll be using the 1 gigabyte per second, 4 original 20,000. Yeah. So this is the layer 2 typology that I showed you a little bit earlier. So basically the root bridge is going to send a packet out which is going to cost basically 0 in numerical value. Once these routers on the end get them to switch B and C, they send back that same packet with a cost of 4. So 4 plus 0 equals the cost of 4. Now when switch B and switch C have both a cost of 4, and they also need to communicate, they send the cost of 4 on the same link to each other, which makes it a cost of 8. The two lower links, the switch B and switch C to switch A, those are going to be your root ports, and that's just because they're smaller value and it's easier to send to your root bridge. Port roles. Some roles are a root port, which is the best port to reach the bridge port. It's the one that costs the least in numerical values. Then there's the designated port, which is the port with the best route to the root bridge on a link. And then the non-designated port, which is all the other ports that are blocking the state, which are in a blocking state. Here's a example of a layer 2 switch that I showed earlier, and it's showing your port roles. From switch A, your root bridge, it's sending out a forward role, which just means that it sends and receives all types of traffic. And your switch B and switch C have root ports. Now if the root ports are the same all the way around, and you're looking for your designated port, then you're going to have to go for the lowest neighbor with the bridge ID, and if that's the same as switch C or switch B, then you're going to have to look for the lowest neighbor port priority, and if that's the same, then you're going to have to look for the lowest neighbor port number. And once you get that, that's when you can find your designated port. And for example, this is where the designated port is going to be. The designated port is decided by the root cost. If they're equal to the lowest bridge ID, then you'd have to go down that line of the same exact line as the root port. And that means that that other connection is the block port. Now I wanted to talk a little bit more about spanning tree protocol states. Now the root bridge has a default timer on them, and most of these switches do. It has a hello message that's sent to each switch. It should take around 2 seconds. Now max age is just hello, and it will send that message 10 times. If nothing happens, then it will send out an error message saying that something's not working correctly. And then there's a forward delay of 15 seconds, which just means that when you're sending out a packet, it'll wait 15 seconds before it says, oh, that's not working, or it is working, basically. The forwarding state is the state where it moves and communicates normally. The blocking state cannot go into forwarding state, but it has to first go into the listening state. The listening state stops loops with a forward delay of 15 seconds, which means that it just listens to, it doesn't receive any information, it doesn't receive the MAC address. And then after that state, then it can go into the learning state. The learning state is another state which has a forward delay of 15 seconds, but this is the state where then it can become into the forwarding state. And this is kind of like how the spanning tree protocol chooses a different server. If a certain link is down, it will go through the blocking state, listening state, learning state, and then back to the forwarding state. So that switch that is the links messed up with will not have any repercussions, but still get the correct information from the main root bridge. This is a little example of what that would look like. So basically, the block port goes away, the information would go from switch A to switch C to the root port, and then that block port will turn into its designated port, which will then send information to switch B. Finally, I just wanted to let you guys know about some types of the spanning tree protocol. First, there's the 802.1d, which is the earliest version. It takes less resources. It's a one tree, one root bridge, which means it's not very good for big networks. There's a PVST Plus, which is one tree for every VLAN, which is really good because you can have certain switches on certain VLANs and have a certain switch be your root bridge, and it makes it a little bit easier. Then there's RSTP, which is one tree, one root bridge type system. And there's Rapid PVST, which is a little bit more intensive than PVST, but it also has one root bridge for every VLAN. I just want to say thank you for watching, and I hope you learned something. Have a great day.